Okay, so we're going to look at this question here. It's a binomial question. You should have the question sheet on the PowerPoint that I've put out, and this is just how I'm going to answer it for you. So the question says, it is known that on an average, one matchbox in 10 contains fewer than 42 matches. 8 boxes are selected at random from a large batch, and the number of boxes that contain fewer than 42 matches is denoted by Y. State 2 conditions needed to model Y by binomial distribution. Okay, well, there's a few ones that we need. We need to have a fixed number of trials. Okay, so here we have 8, I think it is, 8 boxes are selected at random, so we have a fixed number of trials. So we could say that it's needed. There are ones like the Poisson that doesn't need that. So there's that. It's not so contextualized, but you can say that means there are 8 here. Another part to this would be to say that actually the number of matches per box is independent of each other. So that it's independent, and this is a key one, independent for each box. So that's another one, that there's independence. And a third, I know they want 2, but a third one, again as valid, is that probability of success and failure is constant. Okay, so that it's a constant number of fewer than 42 per box. So another one would be that there's a constant number of 42 or fewer in each box. Okay, so that's kind of the probability of success is constant, otherwise it wouldn't work, would it? So they're kind of the two things. So this is to do with the probability of success being constant, and this is to be the fact that the probabilities are independent. And thirdly, you have one that is a fixed number of trials. Then the question says, assume now a binomial model is valid. On Wednesday, 8 boxes are selected, and on Thursday, another 8. Find the probability that on one of these days, there are no boxes containing fewer than 42 matches. And on another day, there are 2 or more boxes that contain fewer than 42 matches. So we've got 2 situations happening here. So I'm going to label situation 1, A, and that is the probability that there are no boxes. So let's just see, model this. This is Y, binomial distribution. Always good to have this written down. N, the number of trials. P, the probability of success. And in this case, that there are fewer than 42 matches. That's our probability of success. So here, I'm looking at the probability that Y, and you have to have Y. If you put X, you'll lose a mark. I'm pretty sure you'll lose a mark. Here, that there are none. So we'd do that. And so therefore, no successes. Now remember, P here is 0.1, Q, the probability of failure, is 1 minus that. So we'd say it's 0.9 to the power of 8. And of course you can use your calculator to work that out, and you should come out with, I believe, that. So that's the first part. What about the second bit? It says, on another day, there are 2 or more boxes. So let's call this B. There are 2 or more. So Y is greater than or equal to 2. Now, when we look at a cumulative distribution, we look at less than. So in order to work this out, what I'm going to do is do 1 minus the probability that Y is less than or equal to 1. And you just have to be really careful that you keep your workings out and you don't slip up on this. Okay, so let's go with that. Now, how do I do this with my calculator? Well, do use your calculator. You can use tables, but calculator. So I need to get to distribution. Here it's number 7. And it's the cumulative distribution. So it's not PD, it's the cumulative one there, 1. And it's a variable. And so what I do is X is 1 or less, so I put 1 in there. The number of trials is 8, and the probability of success is 0.1. So I press equals, and I come out with that value there. Now, be very careful. That's 1 minus that. So that it's very, very easy to forget this bit here, and you can make a mistake. So I'm going to do it straight away. I'll see if this works. 1 minus answer. No. So what I'm going to do, to be clever, I've got a second calculator. Okay? It's always useful to have that. Nick your brothers or your sisters. 1 minus 0.8131047,301. It's really good to have it fully out. So it's 0.187. That might be on fixed mode, so that's on a fixed mode. Crikey crumbers. I'll have to change the fixing on that one. I'm not going to do it now. I'm going to leave it like that just to show you how to do this. There might be a typo, there might be a rounding up error, but just for the sake of me running this video, I'm going to do that. So that's another thing to do, is check your fixing. This is fixed to 3 decimal places. Bit of a bind when that happens, so you could have some rounding up errors. Now, we've got these 2 situations. We've got 2 answers. That's the probability that y is 0, and that's the probability that y is greater than or equal to 2. Now, it says it can be on either day. So it could be on Wednesday or Thursday, and you could have event A happening on Wednesday, and, don't forget the times, B happens on Thursday, or, don't forget it means add, event B could happen on the Wednesday and A on the Thursday. So what you've got here, because these are independent, effectively what you've got is you're saying it's 2 times the probability of A, 0.4305, times the probability of B, 0.187, bearing in mind my rounding up issues. But look, I've kept it in there so I can then adjust afterwards. Times 0.4305 times 2 equals 0.161 to 3 sig fig. So there we go. So the answer is that. It's 3 sig fig. Hope that's helped.